So our first plenary speaker of the afternoon is Professor Vladimir Voeikov from the University of Moscow in Russia, who is going to talk about the work of Professor Alexander Konovalov on nanoassociates in highly diluted solution. Professor Voeikov.
Thank you very much. Thank you very much, ladies and gentlemen. It is my privilege and my pleasure to give a talk here before this distinguished auditorium. And of course, my first words of gratitude are to Lord Ward Atherton for invitation here and to my mind for organization of the most interesting and excellent meeting which, well, at least in several years I participate in. I'm going to talk about the works of Professor Alexander Konovalov. Later in my talk, I'll give more details about his biography and his distinguished activity in Soviet and Russian science. And this talk, of course, not only just the presentation of his works, but also discussion. What he has done is connected to all the novelties which appeared in emerging water science during the last 15-20 years. And you've heard here the two brilliant presentations of Professors Jerry Pollack and Brian Henderson, who already gave a lot of indications that science, I mean physical and chemical science, on which modern biology, biomedicine, bioveterinary, agriculture, and so on is based. So the foundation is changing. And in what I'm going to tell you, I'll give you some examples of drastic changes in what we call now fundamental sciences. But I would like to warn that I'll start from a little primitive, probably, few primitive slides for you, for this distinguished auditorium, because I'm not a homeopath at all. I'm, better to say, patient. And better not to be patient, but if to be patient, then of a homeopathic medical doctor, I prefer. I'm a biophysicist and biologist by education, and Professor Konovalov is a pure chemist. And so when we begin to study the physics and chemistry of aqueous systems, I also work in this field, we had to know what is homeopathy, because they do not teach homeopathy, of course, in faculties of biology, physics, chemistry, geology, and astronomy. So I'll give you just the very brief, for us at least, definition of homeopathy. That is the word derived from Greek homoids, like, and pathos, suffering. And this system was developed more than 200 years ago by the outstanding German medical doctor Hahnemann. Yesterday I had the great pleasure, I was happy to meet his descendant, who just carries, so to say, this flag. And so it is, in a nutshell, homeopathy is based on the idea that patient may be cured with minute doses of natural materials, which in larger doses cause pathological conditions from which the patient suffers. So very well known to this auditorium principle, like cures like. So what minus doses? So what are minus doses? Minus doses of a poison should be such doses which do not poison. So you need to decrease these doses, and it turned out that it is not simple. You take a very small piece of a poison and dilute it in a barrel of water and get minus doses. It turned out that there should be a very special technology for preparation of a remedy with these minus doses. dilutions. And this remedy is prepared first when you have this natural compound which is extracted with water or aqueous ethanol, mother tincture. This mother tincture is subjected to sequence of dilutions in the same solvent, and also very considerable agitation, succussion between dilution steps is necessary for turning an inactive dilution into an active remedy. I will not go into history how Hahnemann and his followers came to this succussion, which is very much needed. It was not originally they came to this idea. It was they came to this succussion, agitation from their observations of the strength of this remedy. And so here on the bottom you can see the scheme of these succussions. Here are centesimal dilutions, which may go to, as we'll see, to tens, hundreds, or thousands of consecutive steps. Okay, it was told here a lot that this very outdated from the point of view of my colleagues at the Faculty of Biology, or the Faculty of Chemistry procedure, this very outdated, ancient from the point of view of contemporary molecular biologists procedure and idea shouldn't work. It was told here. And most people, they do not read scientific papers in which this impossibility of homeopathy is proved. They go to what they called a free encyclopedia. Now most people get their knowledge from free encyclopedia, which is called Wikipedia. And here are these from very, very big article devoted to homeopathy. It's written that homeopathy is pseudoscience, its dogmas are contradicted by a wide range of discoveries, biology, physiology, physics, and chemistry. The page I just took the copy past of the page, which was last edited several days ago only, on the 4th of July this year. So this is free encyclopedia. Please, somebody, please try to write in this free encyclopedia the article about homeopathy with the opposite point of view. I'm not sure that you'll be successful. Okay. So why this, what are these laws of biology, physiology, physics, and chemistry, and geology, and astronomy, which homeopathy contradicts? Well, it's just, I'm kidding a little, of course. What is, why it contradicts biology, and from biology, medicine also? Because homeopathy challenges the major postulate of the contemporary biology, that all biological processes are based on specific local interactions of biomolecules, for example, substrates and enzymes, hormones and receptors, antibody and what antibody interacts with, please remind me, and antigen. And after this interaction, somehow by diffusion they find each other, there is induced fit of one of the partners, and there is the biochemical and then physiological result of the effect. And what are minor doses? In these minor doses, you have such a small quantity of those one of the partners or both of the partners are so small in quantity, they practically cannot meet each other and produce any effect. So this key and lock principle, which is just, we continue to teach all our biomedical students this key and lock principle. Of course, it contradicts homeopathy, but this principle is not a theory, as a matter of fact, like there are very, very few theories, real theories in science. like Earth is round. This is just theory which is established. Nobody would say that it is a cube or flat, at least. But this hypothesis still is supported by a lot of empirical studies. And I would remind you that it appeared at the end of the 19th century. It was launched by outstanding biologists and chemists, Emil Fischer, in order to explain how molecules can interact with each other. Though neither Paul Ehrlich, the founder of immunology, nor Emil Fischer, they never insisted that this is the only way of interaction of molecules with each other. This claim already the maldevelopment of their ideas. However, there are many facts not explained by these hypotheses, and a wide range of discoveries across biology, physics, and chemistry made during the last century suggest that there may be alternative mechanisms of interactions in biology. I would I'd like just to tell you that teaching students physical chemical biology, so-called, we base the basement for physical chemical biology is the science of the 19th century, practically nothing from the science of the 20th century, like quantum physics, the nonlinear thermodynamics, free radical reactions, they do not mentioned in study courses for students there. Okay, so who is right? Those who say that this hypothesis is the only one, or those who say that it is not the only one? There may be other hypotheses. So in order to understand if homeopathy has any scientific foundation or it doesn't have it, we should ask the first question to be answered before any disputes about homeopathic clinical efficiency start. Do serially these agitated ultra-high dilutions of mother tincture differ in their activity, I mean functional activity, biological activity, medical activity, and which is more important for physics and chemistry, in their physical-chemical properties from pure solvent, for example, water or water-alcohol mixtures, when concentration of an active substance in them becomes negligible. For example, 12C dilutions, that is dilution, why I chosen this dilution, because it is so very close to so-called Avogadro number, that is the theoretical, as I meant to say, concentration at which there may be only one molecule in 1 liter. Nobody, of course, could trace this molecule in this 1 liter or even in 1 milliliter and so on. So does this dilution 12C is different from water with which all these dilutions were performed during preparation of this supposedly remedy? If there is no difference between these two samples, then homeopathy, of course, is dilution. Of course, there is no difference in temperature, for example, or in transparency, for example, or in some other properties. In taste, there is no, I suppose, difference between them. And people may say that, no, there is no difference. But if we apply the modern science and try to see using the conventional but modern scientific methods, we may see that there is difference. And if there is difference, then homeopathy has scientific foundation. Okay, I will return to the famous person who was already mentioned in the first lecture today, to the work of martyr of science, I would say, Jacques Benveniste. why I would like to return to him, because first he is famous, and second, because 2 weeks ago there was a 30-year anniversary of his famous or infamous, who likes different things in nature, where he entitled that human basophil degranulation triggered by very dilute antiserum against IgE, and he claimed that practically under very high dilution there are no molecules in this diluted antiserum, and they suggested that water could act as a template for the molecular. And this publication triggered the hot discussion about the reality of homeopathy and about the ability of water to be a subject of memory. I'll just remind you just the essence of this work, which is remembered 30 years past since its publication in Nature, and still the disputes continue about this work. Though I would like to mention that there are at least a dozen papers of completely independent authors who reproduced Benveniste's results. Whatever the so-called skeptics write in their papers that it was irreproducible, it is reproduced. So what he studied? Well, what is basophil degranulation? Basophils are white blood cells which contain granules containing the biologically active substances like histamine and some others. And when these basophils meet some anti-allergens or artificially prepared antibodies against immunoglobulin E, that's molecules who are sitting on the surface of these basophils, they are activated and the granules are secreted into environment. The method was developed by Benveniste before he turned into a heretic, and it is used into many other laboratories. And so what happens when you add this anti-IgE serum to basophils? Here is the basophil degranulation percent of cells which are present in suspension. Then this normal, so to say, concentration of antigens, of antibodies, there is degranulation, then concentration decreases and the effect disappears. But what happens if you continue? Practically 99.9% of scientists who study such similar dose-response effects, they stop here because it's clear if you dilute it further, from nowhere the effect may appear. But if Benveniste and his followers make further dilution, then effect after disappearance again appeared, then again disappeared, then again appeared, and so on. And here at this scale are the decimal dilutions of the solution. So at decimal dilution 22, there is 1 molecule in a liter, and he adds several microliters to these basophil cells. And here is 10 to the minus 60. So what is this? It is 1 molecule in the universe, probably, and still there is effect. So these are what we will call for the ultra-high dilutions. Dilutions whose effect begin to be realized when practically the effect of antibodies which are supposed to present in this serum practically disappears. Okay, so this work was published in Nature. And after this publication, there was a very long pseudo-scientific history around it. It was not science, it was, I would say, just the science politics around this paper. And until now, so this paper attracts a lot of attention, both of those who wanted to reproduce this work and of those who said that it is impossible. But I suppose Jerry said such a word that he found an old hat. Yes, there is such a notion. So it was what Benveniste has done, and he didn't know this, as a matter of fact, that he found an old hat. Jacques Benveniste wasn't the first to discover biological activity or functional activity of ultra-high dilutions. For example, in Journal of American Institute of Homeopathy in 1955, there was published a review in which findings of 25 investigators into the action of dilutions greater than 10 to the minus 24 were reviewed. Of course, we don't have time and so on just to review all these papers, which were published since 1880s, where in these papers, these German medical biologists tested the Aconitum napellus in dilutions 10 to minus 4,000. That is, well, incredible. At that time, people were not afraid to go so far because there were no skeptics and commissions fighting the pseudoscience. So they could more freely make the experiments. So these first papers appear there, and I would like to say that among these 25 papers, there were at least 5 papers, or even more, which were made in Russia before the revolution and in Soviet Union at that time. I have no time to dwell on these papers, but I would like to say that 100 years after the first publications of these ultra-high dilutions in Russia, there started large-scale studies of biological effects of ultra-high dilution of biologically active compounds in the Institute, Academician Institute, Institute of Soviet and then Russian Academy of Sciences of Biochemical Physics. And the leader of this work was the vice director of this institute, Professor Elena Burlakova. It was a big surprise. She was not a medical doctor. She was not even a biologist. She was a chemist. And I know very, very few chemists who study these ultra-high dilutions. But when they, and further on I'll speak about Professor Konovalov's, begin this research, they get sometimes much better results than usually medical people and biological people, because chemists are very organized people in general. Burlakova published in 2007 the review, which contains more than 100 references, not only, of course, Benveniste and his followers, but a great number of papers where they demonstrated biological and functional effects of ultra-low doses of biologically active compounds. It is interesting to say that more than half of these 100 papers were published, unfortunately, only in Russian, and they're completely unknown to the outside world. Okay, but I'll just dwell on one program which they were developing in this institute for at least 25 years. They're chemists, so they synthesized different biologically active substances, and one of them, this synthetic compound, potassium phenazane. I'll talk about this compound because first, it is just synthetic. That means it is clear from any point of view. And second, that this substance, here is this molecular, somehow demonstrated a very wide range of biological and functional activities. As a matter of fact, this substance in ultra-low doses is anti-aging and anti-cancer, and that was proved in many experiments there in Russia. So here is the dose-response effect of this potassium phenazane, not on cells like Benveniste was doing this, but on an isolated enzyme, protein kinase. And so you see, so you have some concentration, not very, very low concentration of this enzyme in a solution, and you have diluted this molecular potassium phenazane to 10 to the minus 18. don't calculate how many molecules are in 10 to the minus 18. It is a calculated concentration because, in fact, there may be no molecules there because during dilution, it is not the ideal dilution concentration. I will not go into details. But the thing is that how can lock and key mechanism explain activation up to 10 to the 9 enzyme molecules which are present in this preparation with one ligand molecule if you take this just calculation? In fact, it may be 0. So lock and key already here doesn't work at all. Since Burlakova was a chemist, and so the chemist had to believe in her experiment, not her, I mean her school experiments. It was a very just advanced school of chemistry. Then this preservation of biological activity in aqueous ultra-high dilution in experiments of Burlakova motivated Alexander Konovalov already 10, 12 years ago to study physical chemical properties of aqueous ultra-high dilutions of preparation of biologically active compounds. As a chemist, of course, he understood that one molecular to 10 to the minus 9 cannot activate 10 to the minus 9 molecular by even if it runs like a football player very fast, you see, from one molecule to another. It's simply impossible. And he understood that something happens to water. So he decided, being a chemist, he decided to study the properties of agitated water as a consult, pure water, which was used for dilution, with these preparations, highly diluted preparations of different physical and chemical compounds. And so it is his saying that we share general accepted point of view that the number of molecules of an active substance in ultra highly diluted solution is too small for inducing biological effects. And then he asked the question which practically no chemists were too brave to ask. So maybe diluted solutions are not solutions, but something else. And in order to understand if there's something else, he used a conventional high-precision laboratory equipment. Now, in order to I return back. I would like just to give some curriculum vitae of this scientist. He is not a young man. He graduated, Alexander Ivanovich Konovalov, he graduated from Kazan State University in 1956. And Kazan State University is the second university in age after Moscow State University, in which I work. It is an outstanding university. Jerry visited it. Then, 12 years after graduation from this university, he became the dean of the chemical faculty. Then, for 11 years, he was a rector of this university. Then he was for more than 20 years chairman of the Department of Organic Chemistry, director of the Institute of Organic and Physical Chemistry. In 1992, he became the full member of Russian Academy of Sciences, head of Kazan Scientific Center of Russian Academy of Sciences. Of course, currently he is not keeping any official posts. He is the council of RAS, and he has his small scientific, I'll show by the end of this lecture, his scientific group in this Institute of Organic and Physical Chemistry. So what he decided to do? He decided to study these dilutions, ultra-high dilutions, using standard commercial high-precision laboratory equipment. And he studied such properties, studied using such approaches. Dynamic light scattering. I will not go, of course, into details. So this method, very advanced method, it identifies the presence of particles in water and measures their dimensions in a very wide range of dimensions. And also it measures surface charge, if any particles have this surface charge. Then a very new method, nanoparticle tracking analysis. It also measures size of nanoparticles if they are present there, but also measuring particle concentration. And also the properties of dilution as it is, the precision conductometry. Of course, he measured other properties like surface tension, about which Jerry said in his lecture that surface tension is not just one monolayer of water molecules. It may report about the interesting properties of this solution, pH, and so on. So when he took for these studies the substance which was very well known to Burlakova, this phenazane, and begin to use dynamic light scattering of these potassium phenazane solutions, he found that though this potassium phenazane solution is very easily soluble substance in water, and we expect that it should disperse into single molecules in water, and diameter of these molecules are less than 2 nanometers. But when he used this dynamic light scattering, he could see that the first, and we'll dwell on this later on. First, the normal solution, which contains concentration below 10 to the minus 6. They contain particles with dimensions about 300 nanometers. It's 0.3 micron. In order to have an idea what is this, one E. coli, one bacterial cell is 1 micron. So it's very big things which are present there. And when he goes further, dilutes, it doesn't disappear at these particles, and they become simply larger or smaller depending on this dilution. So in this ultra-high diluted, in this range, there should be no phenazane molecules at all, but these nanoparticles are present. And Konovalov, understanding that they consist mostly of water molecules, gave them the name Nanoassociates. Okay, second, this method, DLS, dynamic light scattering, allows to measure if there are particles, if they have surface charge. And it turned out a very unexpected thing. So the particles which were present in normal concentration, they had positive electrical charge on their surface. But when he went to dilutions, the charge changed so it became negative charge. So these particles, which could not contain original molecules, they were not just some particles, but they also had charge which was different from charge which contained these phenazane molecules. So that means these nanoassociates are charged negatively and present there. So this method is a little, it's not direct method of measuring the properties of molecules. The method which is called the nanoparticle tracking analysis allows, so it's kind of a microscopy. So it allows to see these particles with not naked but armed eye. So these particles which are present in this highly diluted solution of another compound, calixaren, you see they are present there. They are illuminated with laser beam and reflect light. So particles are present in these solutions which practically contain no molecules. Okay. Jerry mentioned the works of our Italian friends earlier, Vittorio Elia, Roberto Germano, and some others, who found that under specific conditions, there in water, there may emerge some water which do not evaporate, not only at room temperature, but even at temperature hundreds of degrees. And in fact, it turned out that nanoassociates, unlike usual water, do not evaporate in deep vacuum and at room temperature. And that's why they may be visualized using transmission electron microscopy. I was present at the Alexander Konovalov lecture in the Institute of General Physics, very important institute of the Russian Academy of Science. And when he said that they could see these nanoparticles using electron microscopy, so there was a laugh in the hall. These physicists couldn't believe that it can exist. Now it really exists. For example, another compound, polyoxidonium, the dried compound 10 to the minus 8, calculated concentration 10 to the minus 10. You can see these particles. So these nanoparticles exist, and their existence is supported by different, proved by different methods. Why they were there were studies of water for more than 100 years. Why nanoassociates were discovered only very recently? You see, it's a situation here, it is more difficult than with easy water, because Jerry writes in his book that easy water people observed in 1930s already, simply didn't pay attention to it. Nanoassociates could not be discovered before, because it turned out that the estimated concentrations in ultra-high dilutions of potassium phenazane, for example, is 10 power 8 particles per milliliter. Well, big figure. But what it means that this nanoassociate, if to take in consideration their dimensions, they occupy 10 to the minus 5 milliliter in 1 milliliter, or 0.001%. So their abundance in this water is very, very, very small. And of course, without very sensitive new methods, it was impossible to see. Water is transparent for usual methods of its analysis. So that's why they were not discovered before such sensitive technique appeared. But even after it appeared, only very few scientists, researchers ventured to use it for examination of pure water, because most of other scientists were pretty sure that pure water is pure water. It doesn't contain anything except for dust or some impurities. Purify it better and you'll get pure water. Now, nanoassociates are present in this water in very, very small concentrations. But do they only give these peculiarities to these preparations? It turned out that this water, which contains such a small quantity of nanoassociates, exhibits not classical behavior. When they measure electrical conductivity of these phenazane dilutions, it turned out that even when there were no phenazane molecules at all in these preparations, the electrical conductivity was still much higher than electrical conductivity of ultra-pure water, which was used for dilutions. So it is not only nanoassociates by themselves, due to their lower concentration, they could not be responsible for this increase in electrical conductivity. That means that the whole preparation was different from pure water. Surface tension is also changes in polyphasic non-monotonously in this manner. Okay, I am talking about phenazane and some few other compounds. Now, in fact, the research was performed with tremendous quantity of different compounds. Preparation of more than 100 different compounds were studied in this concentration interval. So here are antioxidants, plant hormones, peptides, proteins, synthetic compounds, and so on. And what was also discovered, a very important conclusion was made, that not all compounds could produce these changes with these dilutions and induce formation of nanoassociates. About 25% of solutes do not form nanoassociates, and their highly diluted preparation which were made according to the standard procedure with 10-fold or 100-fold dilution and agitation, they do not differ in their properties from pure water. This is the best control when you take not just pure water and dilute it with another pure water, but you take some substance and the substance doesn't give you the effect which its relative substance does. And recently they started this series of compounds which belong to the same class of benzoic acid. Benzoic acid, salicylic acid, alpha-aminobenzoic acid, aspirin, para-aminosalicylic acid, and it turned out that only these three compounds, this, and this, were giving nanoassociates. And these two, which are so similar, this one only doesn't have this hydroxyl group, and this one has this amino group here. They do not produce nanoassociates at all. They are very similar. And now the question, there is no good answer, what structural properties of molecules allow to produce these paradoxical properties or ultra-high dilutions, and which structural properties are not, do not induce this. Okay. Dynamic light scattering reveals the presence of nanoparticles also in the normal range concentration of solutes. I already paid your attention to the presence of nanoparticles at 10 to the minus 6 concentration of this phenazane, for example. And this presence, which was found not by Konovalov, but some other authors, this is a very important discovery of the physical-chemical science of water in the last 15 years. In recent years, it was found that not only ultra-high preparation behave illegally. By illegally, I just mean that violating the laws of behavior prescribed in textbooks. But what is much more dangerous for those who are the members of the parliaments who prescribe these laws, that normal aqueous solutions of virtually all known substances, from solutions of salts to solutions sugars, solutions of high molecular weight compounds, are also outlaws as well. So what it means, outlaws? This is a paper of one of the authors, Marian Sedlak from Slovenia, whose impact in this new science of solutions is very big. And he claims, not claims, he states that in textbooks, undersaturated solutions of lower molecular mass compounds and mixtures of freely miscible liquids are considered as homogeneous. However, growing experimental evidence reveals that this is not the case. So what we just, when we put a teaspoon of sugar into a glass of water and dissolve this sugar in water, we believe, so we just see that there is no sugar crystals there already, they dissolved, and from our textbooks we know that sugar molecules are dispersed and there are single molecules after this in this solution. In fact, this is not the case. Here is the nanoparticle trace analysis of some solution of sugar or salt. It doesn't matter, all of them give these nanoparticles. So now we come, and it is only the last 10 years, to the ideas, to the notion that solutions have domain structures, that aqueous solutions of all studied solutes contain giant characters, domains. I prefer to call them clouds. Jerry Pollack already demonstrated to you that the clouds emerge in the blue sky from what? From water which was initially dispersed. And in recent years, it was discovered that large-scale structures this, and this, with sizes for hundreds nanometers in diameter, are present in different aqueous solutions and mixtures. And what is interesting, that when you first dissolve sugar in water, it is first is dispersed, and then clouds begin to form. And sometimes the formation of clouds takes hours or even days. So this is the process, in fact, of kind of self-organization. And upon dilution, domains these do not disappear, and their size is usually grows up. So textbook concepts concerning the properties of aqueous solution need just very, very serious revision. First, it means that usual solutions of highly hydrophilic compounds are non-homogeneous systems, that solid molecules partially condensate in clouds, floating in more homogeneous solutions. And dimensions, what is interesting of clouds, upon dilution, they increase. Clouds do not disperse, but they become larger and larger the less quantity of solutes are in this solution. Now, we were talking first about nanoassociates at very high dilutions. And here we are talking about these domains or clouds in normal concentration of solutions. And the question is, what is the relationship between these domains in sugar solution, for example, in tea, and nanoassociates when you dilute this tea 10 power 24 times? Is there a boundary between normal solutions, which contain clouds, and ultra-highly diluted systems where solutes may be practically absent? And what is very important, that Konovalov discovered that this boundary exists, and its existence is defined by the presence of ambient electromagnetic field. So this discovery was made when preparations with different concentrations of solutes were carefully shielded from the electromagnetic fields, which are everywhere in this room also. Well, at least 50 hertz is everywhere, and now having a lot of gadgets, it's more different other frequencies. So if to shield solutions from ambient electromagnetic fields with the permalloy screen, then what happens? The nanoassociates disappear. Electromagnetic fields are necessary for formation of nanoassociates. If you have ultra-high dilution of something, and keep it at the 18 hours at the laboratory table where it is affected by ambient electromagnetic fields, or put it into a screen it into a barrel containing this permalloy, which attenuates its electromagnetic field up to 5,000 times, then what happens? Again, I've shown you many times this dose-response curve for phenazane, potassium phenazane. And it turns out that shielded, this is red curve, solutions, they produce domains under normal range of concentration. But when you go to lower concentrations, there are no nanoassociates here, if it was shielded and kept in this permalloy screen at least for 18 hours after preparation. So that means that for phenazane, potassium, and for all other substances who are able to make nanoassociates, there exists some specific concentration, which is called critical concentrations, below which nanoassociates in preparations shielded from electromagnetic fields do not emerge. For phenazane, potassium phenazane, it is 10 to the minus 7 molar. Above 10 to the minus 7 molar, we have normal, though abnormal again from the textbook point of view, solution. Below 10 to the minus 7 molar, below this concentration, we have what we call ultra-high dilution, because it is, can exist only if it is under the action of external electromagnetic field. So only in the presence of ambient electromagnetic fields, nanoassociates emerge in ultra-high diluted preparations, and paradoxical properties of these preparations, including their functional activities, also emerge only in the presence of ambient electromagnetic fields. So already at this point, the question of, I would say, ordinary chemists, not like Burlakova or Konovalov, that we cannot explain from the point of view of chemistry effect of ultra-high dilutions. This is not just chemistry, this is also physics. Without ambient electromagnetic fields, upon which chemists do not pay attention at all, there is no ultra-high dilutions which have specificity. For example, electrical conductivity after shielding is electrical conductivity of pure water. Surface tension is surface tension of pure water. These are red curves. And also what is important, the biological activity of this, in this case, this phenazane solution completely is absent in preparations of the same dilution after shielding the original, after shielding these dilutions. While black curve, that's without shielding. So I need to come to the end because after me there will be another very interesting lecture, of course. And I'm coming to a brief summary concerning ultra-high dilutions. First, nano-sized from 100 to 400 nanometers negatively charged associates. Nanoassociates are present in ultra-high dilutions preparations of most substances. The dominating content of nanoassociates is water. Why I do not say the only content of nanoassociates is water? Because there are indications that this is not only water, but it is also nitrogen, oxygen, carbon dioxide, because it is impossible to prepare these preparations without succussion. That means without pumping gas into the solution. Size, charge of nanoassociates, as well as the electrical conductivity, surface tension, pH, varies in multi-phase pattern with several dilutions. And these preparations of most substances possessing these peculiar physical chemical properties demonstrate functional activity in test systems. I told you about the work of Alexander Konovalov, but is it a scientific fact or just observation of a genius who was making his experiments in shielded conditions? Any scientific observation becomes scientific fact only when it is not unique but confirmed by independent scholars. And his observations are scientific facts because, well, I can give you many references, but just I took there only those where you have existence of stable water clusters at room temperature and normal pressure. Experimental evidence of stable water nanostructures in extremely dilute solutions at standard pressure and temperature. Nano-sized solvent superstructures in ultramolecular aqueous dilutions, 20 years research using nuclear molecular resonance. All these authors were working completely independently, one from another, and they got not identical, but very fundamentally same results. So, in fact, Konovalov's question was, are these solutions really solutions? In fact, it turns out that there are no solutions, practically no solutions, in the classical sense of the word. And what are these, what we call now solutions? In fact, these are not solutions. Most aqueous systems, they are rather self-organizing, dispersed systems. What is self-organizing? Because I told you when you initially dilute salt or sugar in water, there it is solution. But if you let it stand, then clouds appear and they may form for a very long period of time. That is self-organization, and this self-organization is making So you have these clouds here. There are multiple potential differences between phases, making system non-equilibrium. I'll just refer to what Jerry Pollack was talking about, charge separation. And here is also charge separation. This is charged negatively, and here is positive charge should be around. So all these systems are non-equilibrium. That means that they have potential, and not only potential, but also kinetic energy. Okay, thus physical chemical properties of ultra-high diluted preparations are drastically different from properties of pure water and of dispersed systems with normal concentrations of solutes. Though these dispersed systems with normal concentration of solutes are drastically differ from textbook solutions. Yes, I just have these 5 minutes. The presence of nanoassociates preparations correlate with their functional activity. But the mechanism of functional activity and biological action of ultra-high dilution preparation of biologically active compound needs further investigation. The question was, do they differ? The answer is yes. Highly diluted solution do differ from water which was used for this dilution. But why they produce their functional effects, why they produce biological effects, this already needs further investigation, because but we already got the premises for this further investigation. They are electrically charged, they are non-equilibrium, being non-equilibrium, they possess biological activity. Okay, coming to the end, I would like say now that already now it is obvious that this mechanism of key and lock, the mechanism of their action may be associated in no case with classical and mechanistic key and lock concept suggestion of the 19th century. But there is another key and lock concept which exists now. And here is the analogy with key and lock concept of the 21st century based on resonance interaction is much more relevant. You may open with your key your car, which is standing tens of meters from you. You may give an order to an explorer on Mars, just the distance of 1 million kilometers, and it will obey your orders. It will get information, make some work, and return back the result to you. So this modern key and lock concept describes much more accurate and selective action at a distance. And it is realized in modern technologies due to application of the principle of quantum field theory, which I'm pretty sure will be the physical foundation of the development in this field. Okay, so I asked at the beginning the question, is ultra-high dilution equal to water? No, it is not equal. And that means that homeopathy has a scientific foundation. But the problem of clinical efficiency of homeopathic treatment should be discussed by medical doctors. Like, as a matter of fact, the problem of clinical efficiency of non-homeopathic treatment as well. Here, there is no difference now between allopathy and homeopathy. Allopathy may be also the placebo effect, and there is a lot of descriptions of placebo effect of allopathy. So that is now discussion, not of physicists and chemists. That's discussion between you. And I would like to show this small group of academician Alexander Konovalov and his colleagues, very few young people, and Irina Rishkina, his very close associate. I was also present in their laboratories, so March 2018. It's a great pity that he himself could not come here, but I hope that I at least managed to show his great impact in modern in science and development of the science to which we belong. Thank you very much.